We're going to take a little bit of time and talk about Lesson 36 today. This is Saxon, Course 2. Lesson 36 has to do with ratio and sample space. Now, we've done some work with ratios and we've done some work with sample space, but we haven't spent tons of time specifically on either one. There's some important vocab when it comes to these two terms. A ratio is a way to describe a relationship between two numbers. For example, if there are 6 boys and 9 girls in a classroom, the ratio of boys to girls are 6 to 9. 6 to 9 is also able to be reduced to 2 to 3, or 2/3. The ratio of 2 to 3 can be written 4 basic ways. It can be written 2 to 3, as in 2, TO, 3. It can be written as 2/3, or actually that's 2 to 3 using the division marker. It looks like a fraction. It can be written as a decimal or a percent, either way. It can be written 2:3. Those are the 4 ways that we basically would see a ratio written. Now, we need to understand that when it comes to ratios, there are always 3 numbers involved. Now you say, how can that be? Well, if you have the ratio 2 to 3, you also have 5 involved, because 2 plus 3 equals 5, and 5 is the total number of items in that ratio. Okay, and that comes into play a little bit more when we're looking at this next part. In a class of 35 students, there are 22 boys. What is the ratio of boys to girls? Now, did they give us the number of girls? No. But we can figure it out because we know we have 35 students total and 22 of those students are girls. So we can subtract 22 from 35 and get 13, and then we would have 22 to 13. We could also write it 22 over 13. We could write it 22 to 13. Okay? And if we wanted to, we could actually turn it into a decimal and come up with a percent for it. Okay, related to this is the ratio of girls to boys. Now, what's the difference? Well, girls are listed first. Order is important. Order is important is a phrase you're going to see a lot more in the next few lessons. So, what is the ratio of girls to boys? There are 13 girls and there are 22 boys. So it's 13 to 22. And of course you could write it as 13 to 22 or 13 to 22, just like that. Okay, in a class of 25 students, there are 15 girls. What is the ratio of boys to girls? Reduce if possible. How many students in a class? Yep, 25. How many girls? There are 15. How many boys? Well, we'll know just as soon as we subtract 15 girls from the total of 25, which ends up to be 10. 10 boys to 15 girls, or 10 to 15, or 10 to 15, and we can reduce it to 2/3. So ratios, not that hard. Okay, let's take a look at another example. Okay, if a wrestler won 7 nights of his matches, what is his win-loss ratio? Okay, he won 7 nights, or 7 out of 9 is what you're thinking here. You're thinking 7 out of 9 of his matches, 7 out of 9. Well, if he has a 7-9 record, that means he won 7 of the 9 matches. 9 minus 7 is 2. So his win-loss ratio looks like 7 and lost 2. So his win-loss ratio is 7 to 2, which you could write as 7:2 or 7 to 2. And a lot of us are into that at this time of year because of the football playoffs and so on. We're really into win-loss ratios. Okay? All right. Let's spend some time talking about probability and sample space. Both of them are pretty easy concepts. Both of them you've been introduced to before. They're not all that difficult. Okay, so let's look a little bit at marbles. I know you love looking at marbles. If there are red marbles and there are black marbles in a bag, okay, if the ratio of red marbles to black marbles is 10 to 12, what fraction of the marbles in the bag are red? Okay, remember earlier I talked about that third number that was always involved with every ratio, the third number? Well, here's where that third number comes in. Find the total marbles in the bag. Well, the ratio is 10 to 12, red to black. So you would add 10 and 12 together and get your 22 marbles. Okay, so that's that third number that we were talking about earlier. Okay, and then you need to create a fraction that compares the ratio of red marbles to the total number of marbles. Red marbles to the total number. Well, we know that red marbles had 10, and we know the total is 22, so it is 10 red to 22 total, reduced by dividing each one by 2, and you get 5/11, or 5 to 11. Remember, as you're thinking, the probability can also be expressed as a percent. The minute you can turn it into a decimal, you can turn it into a percent. Okay, the other thing I want to talk about is sample space. And we have actually had a couple of mini sample space problems. Sample space is a list of all possible outcomes. That's the vocabulary definition of it. Below you'll find on this sheet a sample space, which is a list of all possible outcomes for two coins, both having heads on one side and tails on the other. Now you've done this before. This is not going to be like a big surprise to you. Okay, and then we call these fair coins. Fair coins means that the weight on one side of the coin is exactly the weight on the other. For a long, long time, there was a saying, and still is a saying, that tails never fails. Because if you have a standard coin, especially like a quarter, they always say that the weight of the head of the president, where it sticks out a little bit, makes the head side of the coin heavier, and so it will naturally flip more so that it's tails up and heads down. Don't know if that's true nowadays, but it used to be true. So they just call these fair coins, meaning they're absolutely certain that both sides are exactly equal. Okay, so sample space is just a list of all the possible combinations. So you start with heads, and if you flip heads, one coin heads, the other one could be heads, or it could be tails. If you flip and the first coin lands on tails, the other one could be heads, or the other one could be tails. Right here is your sample space. Okay, this is how you write out the combinations. Okay, I've got one more really good example, and this kind of involves just one more aspect of looking at heads and tails and adding a spinner. Okay, what would a sample space look like if we had a coin and a spinner with 4 parts? So here we go. We got a coin with heads and tails, and we got a spinner with A, B, C, D. Okay, not too tough. Here's your sample space. Remember that the spinner has 4 outcomes and the coin's only going to have 2 outcomes. Coin will only have 2 outcomes. Spinner will have 4. Sample space. Okay, here's your chart. Here's your chart. Okay, you could have heads on the coin and A on the spinner, heads and B, heads and C, heads and D. Or you could have tails on the coin and A on the spinner, B on the spinner, C on the spinner, D on the spinner. How many total outcomes is that? It's 8. Did you happen to notice 8 possible combinations? There were 2 possible combinations on the coin and 4 possible combinations on the spinner. Do you suppose it is just coincidental that the total outcomes are 8? Don't think so. Okay, what is the chance, we'll come back to that, what is the chance of flipping heads and spinning a D? Well, if you look at the sample space, heads and a D, there's only one. 1 out of 8. 1 out of 8, or 1 in 8. You actually can go to your sample space and figure that out. Now, I want to show you one more. This one's just a little bit more complicated, and you need to know this. This is called the fundamental counting principle. and you need to write this down. If there are m ways for A to occur and n ways for B to occur, then there are m times n ways for A and B to occur together. Basically, if there's 3 ways for something to occur and 4 ways for something else to occur, 4 times 3 is 12, which I just explained when I went over the 2 times 4 is 8 on the last slide. Okay, so we have spinner A and spinner B. Really need you to put this in your notes. Spinner A and spinner B. Okay, spinner A has 4 possible outcomes. Spinner B has 8 possible outcomes. Before we ever look at the chart, how many outcomes should we have? Think about it for a second. 4 times 8, 32. I bet you're right. I bet it'll be 32. Now, look at the chart. Okay? Down here, we have A in the first spinner. A could spin first and get 1 through 8. I'm going to move this up so you can see it better. Okay? A first, 1, 2, 3, 4, 5, 6, 7, 8. And then, oh my goodness, B could be first. And then what would we have? B, 1, 2, 3, 4, 5, 6, 7, 8. And then it could be C first. 1, 2, 3, 4, 5, 6, 7, 8. Oh, yeah, and it could be D first. 1, 2, 3, 4, 5, 6, 7, 8. When we get all done, here's your sample space chart. It could roll, you could spin A first with 1, could spin B first with 1, C first with 1, D first with 1, A with 2, B with 2, C with 2, etc. Okay? Or you can look at it up and down. A1, A2, A3, A4, A5, etc. But when it comes down to it, there are 8 in each category. There's 4 rows. 4 times 8 is 32. Cool stuff. Fundamental counting principle is a very cool thing, and it really, really works. It says that the number of outcomes is going to be 4 times 8, which is the total parts on each spinner multiplied times each other. We just proved it. I hope this was helpful. I hope you had a great day, and I hope that you enjoyed watching this video. Have a great rest of your day.